Hi, my name's Lizzie and I'm here today to talk to you about supporting beneficial insects. Thanks so much for the invite to present from the Mid-Murray Landcare group. This is a topic that I'm really passionate about and I'm so excited to share a little bit of my knowledge about insects in Australia, how we can support them in agriculture and just how important they are for our ecosystems. So I'm here today representing Invertebrates Australia. We're an NGO that was established in 2021 in response to the mega fires that happened over east and just really wanting to contribute to the conservation of these amazing animals. Our mission is to provide an integrated scientific approach to the conservation and promotion of all Australian invertebrates. And our vision is a future where invertebrates are appreciated and valued for their biodiversity, and which is sustained across Australian lands and waters. So we're a group of people that are really passionate about insects and all the other invertebrates, and we're just here to use science to think about how we can conserve them better in Australia. So what are we talking about when we say invertebrates in Australia? So it's not just insects, it's the slugs and snails, even the jellyfish, the spiders, the scorpions, and there are over 100,000 species in Australia which have scientific names. So we are able to recognise them, they have a designated name. But it's likely that there's actually 3 times as many as that species that actually haven't even been identified in Australia yet. So we're dealing with this hugely diverse group of invertebrates that often we don't actually know very much about them. What we do know is that in Australia we have 450 endemic invertebrate species that are threatened, and so this is species that we have enough information about to know how much danger they're in, and it's likely that the problem is much bigger than this, but we're just starting to understand how threatened invertebrates are in Australia and across the world at the moment. And this is kind of important because invertebrates are just so important. They are vital contributors to all ecosystems. They keep everything ticking along, they keep everything functioning. And when we're talking about agriculture, it's pretty widely understood that invertebrates are required for pollination of a vast majority of the crops that we grow. There was a study that came out recently that tried to put a number on just how valuable they are, and they came up with $57 billion a year just in the US. So that's kind of giving you an idea of how much they contribute to. Now, we'll be talking a little bit about ecosystem services and biological control today, and if we're looking at how valuable that kind of service that's provided and that biological control is worth, we're looking at kind of $72 per hectare is a number that has been brought out of some other studies, but overall it's estimated that tens of billions of dollars worth of pest control services are provided by invertebrates across the world. So they are really huge contributors to agriculture and the way that we grow our food, which is why I'm here to talk to you about it today. Now, when we talk about ecosystem services relating to invertebrates, there's some here that will be very familiar to everyone, and there will be other speakers at this event about things like pollination. We know how important it is to have bees to pollinate our crops. But other things that we might not know quite so much about for invertebrates are things like decomposition. So it's really important to have biodiverse groups of invertebrates living in that soil so they can break down the organic matter, get those nutrients back into the soil. Invertebrates are also a really important source of food for a lot of native species in Australia, so particularly birds, mammals and reptiles that rely on having large invertebrate populations to feed on. Seed dispersal is a really interesting one. There are a whole lot of plants in Australia that have evolved this relationships with insects, especially ants, where they tempt them to eat their seeds or to eat a small part of their seed, and with ants they take them back into their nest and then bury them further away. So the plants are actually using insects such as these ants to distribute their seeds for them. I've got medicine and materials there because there's amazing advances in science at the moment that are looking at using particular proteins and chemicals that invertebrates use, things like their venom that can be used from everything from creating new biopesticides to curing cancer. So we're finding these amazing new ways to use all these proteins that invertebrates have evolved as part of their bodies. I also have education there because We do a lot of work with schools, we do a lot of work with local communities, and we really do believe that it's absolutely essential to understand your environment, to want to be able to, conserve it and to be able to engage with it. And what better way to engage with nature than to step out your back garden and get to know insects and bugs that are living there. So we think that having invertebrates in our ecosystems is a service to us because it helps us understand the world that we live in. And finally, up the top there, I've got pest control. So there are hundreds and thousands of species of insects and spiders and other predatory invertebrates that have been evolving for millions of years to eat bugs. They're really good at it. And so I'm going to be talking today a little bit more about how we can use these amazing skills to help us control insects. But of course, it's not just ecosystem services that we get from invertebrates. We've got to also appreciate that there's a flip side and that there are invertebrate species out there that can become pests. So particularly things like mosquitoes and cockroaches can be really bad vectors of disease, especially in urban areas. They can damage plants and crops, and they can also cause damage to property. So there's this flip side of wanting to encourage as much biodiversity of these really important invertebrates as possible, but also controlling the ones that can become pests. And so this is quite a delicate balance between the two. And as I said today, I'm going to be focusing on this idea of how we can use the good bugs in our system, these beneficial predators, to help control for those invertebrates that have become pests in the circumstances such as agriculture. So at the moment, the way that we kind of deal with these pests in our ecosystems is we spray them generally. That's what, over the last 50 to 60 years, we've become quite reliant on using chemicals to deal with these pests, especially in agricultural systems. The problem is that the broad spectrum insecticides we use are, by their very nature, toxic to almost all invertebrates. So this means that they don't just kill the pest that you're trying to kill, they also have both direct and indirect impacts on a whole lot of beneficial species. So a direct impact would be dying straight away from being impacted by that insecticide, but indirect impacts are things like when you hear about the bees not able to navigate back to their hive and things like this, we're actually affecting the ecosystem in ways that we don't even know yet with these chemicals. We also, when you spray a broad spectrum insecticide across the fields, you also have a risk of killing off all of that initial pest, but then leaving a big gap for more pests to come in and cause more problems. So you kind of start this vicious cycle of having to respray when new pests come back out. We're starting to realize just how impactful insecticides can be on soil health as well. It's kind of been an unrecognized area in the past, but because a lot of these chemicals do end up in the soil and impacting those invertebrates, we're now seeing reduction in those decomposition ecosystem services and other ecosystem services as well that are being impacted. And of course, the use of insecticides can also lead to insecticide resistance, where they aren't actually going to be effective of controlling any of those pests anymore. So broadly, what everybody in agriculture is thinking at the moment is how we can move away from using so many of these insecticides. It's a real challenge that we're facing, but having a better understanding about invertebrates and how they work in these ecosystems is really going to benefit us here. The problem is that in Australian agriculture, there is still a very high level of use of broad spectrum insecticides. So we're talking about the organophosphates, pyrethroids, neonicotinoids, and carbamates are still some of the major insecticide groups that are used in Australian agriculture. So we're going to really have to start thinking about how we shift away from these insecticides and how we can integrate more sustainable pest management into our practices. And that's where integrated pest management comes in. It's been around for a couple of decades, and it was developed in agriculture to help give a pathway for decision making when it comes to dealing with a pest problem. It's about trying not to be too reactive and about taking actions beforehand that can reduce the pest becoming a problem. So that whole idea is that you start with the least toxic option, the least level of intervention that you need to, and if that doesn't work, you start moving up the pyramid into the more invasive and more toxic options. So for example, you can remove the weeds that the pests might be feeding on during summer, and that means that they can't move into the crop at the beginning of that cropping season. Things like that that you can do in preparation. as we start looking at more intensive things that can be done on farms, this is when we start talking about using biological control, which I'll talk about a bit more later, and using natural enemies to eat those pests. And then if these methods that we've used haven't worked, then you start thinking about possibly having to use insecticides. But if we do, we try and use the most selective insecticides first. So that would be the ones that are targeted for particular pests. And there is actually some really good chemicals that are out on the market now, which will reduce the impact that you have on those beneficial insects. And the idea with integrated pest management is that if that still hasn't worked, then you can move on to using those more broad spectrum pesticides if absolutely necessary. Integrated pest management isn't about not using chemicals at all. It's just about really reducing that use of them until it's absolutely necessary. And we would often talk about working out what the threshold level for a pest is. So once the numbers get to a certain point, there's been research that will, sometimes there's research available to tell you that once they get past that point, then they're going to cause an economic damage to your pet, to your crop, and that's when you would spray. But of course, the problem is that thresholds don't actually exist for most pests, for a lot of pests in a lot of different agricultural industries in Australia. And so sometimes these ideas are a little bit unclear about when chemicals can be used or should be used and whether there's going to be a risk of crop damage there. And that's the kind of recognition here in that integrated pest management requires a lot of knowledge about what kind of biodiversity exists in that area, what the risks of pests are, and what the pests are doing and what the beneficials are doing. So really understanding and monitoring those pests and beneficials over time. And so the recognition is that integrated pest management can be a little bit more labour and knowledge intensive, but in the long run, it means a reduction in the use of chemicals, which is actually an economic saving as well, and better management practices integrated across the farming systems. So a really integral part of integrated pest management is biological control. So being able to rely on the natural enemies, so these invertebrates that are existing in the populations, to be able to suppress pests underneath the threshold levels where they're going to be doing damage. You're never going to be able to completely eradicate pests, but I think that the idea that getting the pests below a level where they're causing any kind of damage can absolutely be done with biological control. And so biological control can relate to a generalist predator, so an insect that will come in and kind of eat any other pest that's out there, or it can be very highly specialized predators that will only attack a particular type of pests. It will decrease the need for pesticides, but it also relies on having a healthy, balanced ecosystem that will encourage these beneficial insects to be part of those ecologies as well, and that's a really important part. So in Australia, we do know that there are circumstances where these biological control agents, as we would call them, are absolutely able to manage pests, especially when it comes to things like aphids. They're quite readily managed with biological control. It means that we've got a much lower risk of evolving insecticide resistance or losing the efficiency of the chemicals that we currently have. And this is going to be really important in Australian agriculture over the next couple of years because there will be higher regulation of a lot of the chemicals that are currently available, and that's when we're going to have to start relying on biological control a bit more. Biological control can also be brought in instances where insecticide resistance already exists, and that's going to be really important because we're seeing huge numbers of resistance across pests in agricultural in Australia at the moment. And we do already have many species that already exist in our ecosystems that can be important for biological control. And I'm going to explore a couple of these with you now. Some of these are native species that are already in our systems, and I'll talk a bit later about how we can actually be releasing species that don't already exist to support the biological control in our farms. So starting off with one of my favorites, these are ladybirds. A lot of people now will be recognizing that these are really good predators to be having in our farms and gardens. There are predators not just as the adults, the kind of spotty ladybird you'd be very familiar with there, but also as juveniles. So this one on the left is a larvae ladybird. They're these kind of weird spiky little things, and they are voracious aphid predators, particularly at that age. So you'll see that the ladybirds will often lay their eggs right next to a big clutch of aphids, and after those aphids have moved in, you'll very quickly start seeing ladybirds in a healthy ecosystem that will start moving into those areas as well. So even in my back garden at the moment, I've been able to head outside. I've got aphids all over some of my plants, but they've already got ladybirds there. So that's a really encouraging sign, and often a really good insect to look out for to see whether biological control is having an impact in your area. Another group which can be really effective are called carabid beetles. So there are huge numbers of beetles, and even just within this group in Australia, there's over 1,600 species just of carabid beetles. So again, we don't know very much about individual species, but what we do know about these groups of beetles across the board is that they can be very good predators. You can see they've got quite large jaws, they've got those big forward-facing eyes and big strong legs, and they're particularly good at controlling things like slugs and snails. We are starting to see a huge rise in slug problems across kind of southeastern Australia, and we're thinking that some of this might actually relate back to the higher use of seed treatments in some areas, which are putting those chemicals into the soil, which are then being either taken up by the slug or directly taken up by the beetles. And that's the reason why these slug kind of numbers are able to take over, because the slugs aren't being as affected by the chemicals, but when the predators come in and eat those slugs, then they're getting a dose of that chemical and they're reducing their biological control efficiency. So it's really, really important to consider these food webs and these ecosystems and all the different species living in these systems and how they interact. So the big picture here on the right is a beautiful adult carabid beetle, and this one here is what they look like as larvae, and again they're quite good predators as larvae as well, but often get mistaken for pests. So this is where a little bit of knowledge about what a beneficial insect looks like can be great, because instead of going out and seeing a whole lot of these little grubs and thinking you need to spray everything, you then know that biological control is starting to occur, and that's a good thing and can be kept an eye on. Another really great invertebrate biological control agent are hoverflies. These, as adults, are often mistaken for bees because they have this stripy abdomen, and they've actually evolved to look like bees as an anti-predator defense. So they know that a bee will sting a bird or another predator when it tries to be predated on, and so they've evolved to trick these predators into thinking that they're bees, but they're completely harmless. They don't have a stinger. They can actually act as pollinators as adults. You can see this one here is on a flower, but as juveniles, because they're flies, they're maggots. These maggots have these amazing hooked mouth parts that they'll actually get into things like aphids and suck them dry, in a matter of minutes. So this is another instance where having these grubs appear in an aphid field can actually give farmers a lot of anxiety. They worry about what this new pest is doing there, why they've got all these grubs on top of aphids, but it's a really good thing because they're coming in there in response to the aphid outbreaks, and they're acting as biological control agents. So it's a really exciting thing to be able to watch those processes happen. Lacewings are another one of my favorites, and they're gorgeous as adults. They've got these beautiful kind of see-through wings and these large eyes and huge antennae. And again, as juveniles is when they have the most impact as a biological control agent. They're these really funny looking insects as juveniles. You can see here this funny looking thing here. It's got these big jaws at the front. That one's grabbing an aphid, and they collect all of the carcasses of their prey and pile them up on their back as a bit of defense and a bit of camouflage. And so you'll often kind of look down at a group of aphids and see like a bit of trash moving around, and you're trying to wonder what that is, and it's actually a lacewing larvae that's moving along as well. So that's another great one to keep an eye out for. Now, parasitoid wasps, these are quite a gruesome story, I guess, but very, very highly effective biological control agents, in that there are a huge, huge number of species. I'm not even going to try and put a number on them, but hundreds of thousands of species of these tiny, tiny little wasps that lay their insects in pests. So it can be one egg, it can be multiple eggs, it can be inside the pest or on the outside of it. But the idea is they will lay their egg on a host, and then the egg of that wasp will grow up inside the host and then burst out, the kind of alien style. Completely gross, but an amazingly effective way to control pests, especially because some of these wasps will be very, very pest specific. So you can actually release a whole lot of wasps that will only attack one particular type of caterpillar or type of aphid. And there are other wasps that are much more generalist, so they will attack lots of different species. There are lots of these species that are already present in Australian ecosystems, and some that have been introduced to be able to attack particularly introduced pests. The efficiency of these wasps is quite stunning in that they can come in, and there's scientists that have gone out there and had a look at just how many of the pests have been impacted by these wasps, and it's at a level at which it's able to keep these pest numbers under control. The problem with kind of farmers that are out there looking at these pest populations is it's not always obvious whether they have been attacked by these wasps or not, whether the wasps are present or whether they're kind of having these actions. So it can be a really hard thing to kind of also to wait for these wasps to appear and to know whether they're having that job. So this is a difficult one, and it's a circumstance where it can be really key to understand what's going on in these systems, because if you put one spray over, then you've basically stopped these wasps from doing their job. So sometimes it's a matter of waiting and seeing some of the outcomes. Another one that I'll just talk briefly about is called a predatory mite. So again, there's a couple of different species, and people will often just assume that all mites are pests, which is why I talk about this one. But there are these mites, these ones are called snout mites, but there's a number of different types that will actually come in and are very, very good predators of other mites. So if you have spider mites or you have other kind of mites, which can often develop very, very strong insecticide resistance, then having predatory mites such as these guys come in, they're very fast, they're very good predators, and they can deal with those mite problems without the problems of insecticide resistance that a spray would have. Now, just very quickly, one of my favorite biological control agents, the spiders. This is my specialty area, and all of these photos I've taken over the years of different types of spiders I've found in crops. There are a huge number of different species. They are generalists, which means that they'll come into a field and they'll eat all sorts of insects. But if you've got spiders that are in your fields and crops, it's a really, really good sign, because it means you've got healthy, functioning ecosystems. You've got food webs that are moving through. You've got food there for the birds that are going to be coming in, and all the other reptiles. And it's a good measure of a system which is going to be working well. So having lots of different spiders, people might not like this, but it's a really good thing to be having that biodiversity in your field. And just finally, I guess a head nod to like so many of the other species that exist out there. These are again just some photos I've taken over the years of all the different types of predatory insects and invertebrates that are out there. There's things like assassin bugs. Most bugs will kind of use their long mouth parts to suck the inside out of fruit, but these use their mouth parts to suck the inside out of aphids. Things like praying mantids, centipedes. There's so much out there that really, even without having to focus on a particular predator or a particular pest, just increasing the biodiversity of any of these kind of areas is going to have a benefit when it comes to controlling pests. Okay, I'm just going to talk about the two different types of biological control, and then a little bit about what we can be doing on farms. Conservation biological control is when we try and improve the whole environment to be more supportive of a whole range of different types of invertebrates ecosystem service providers. So providing habitat for them, having native plants there, those strips that you can have in farms to support beneficial insects. It does require putting aside a little bit of land, but the benefits of that, of having the pest control, the pollination, the decomposition, more than pays for having that land there. But it also means reducing insecticide use to make sure that those invertebrates can survive and can move into the crop. Now, augmented biological control is a little bit more responsive. It's about knowing what pests are in the crop and then thinking about which species can be released to actually deal with that when it becomes too much of a problem. So there are a couple of really amazing companies out there like Bugs for Bugs, where you can buy up a whole lot of these predators or these parasitoids like the wasps, and you can release them. There's a little picture there of releasing the wasps in one of these little containers. They're discovering new species all the time that can be used to attack new pests, and actually sometimes being able to use species from overseas that are very, very carefully selected to be able to use in our agricultural systems here. There's also a lot of research that's being done into the best release strategies for these biological control agents. And this is a picture here of a drone that's being used to release predatory mites over a field. It's a really exciting new area. So I'll be the first to admit that IPM has its challenges. It does require time and money to understand these systems and to know the best responses, but over time it's a much more economic choice. The difficulty is that pest risk is often unknown. So unlike an insect spray, you can kind of just spray and get rid of all the pests, and that seems like a really low risk kind of option. But the thing is that risk builds over time with insecticide resistance and the risk to the environment. So it's often a matter of understanding what the long-term risk is versus the short-time risk. And invertebrates are so hard to understand kind of their movement patterns and their biology that sometimes we don't know whether a year will be a particularly bad risk for a particular pest or not, and it's quite difficult to prepare. We often don't have enough threshold information, so there's a lot of really good organisations out there at the moment that are trying to build up that information about when we need to kind of trigger different actions. But we do see that a lot of farming communities still rely on those insurance sprays, and we understand that that's a really important part of feeling prepared for the year, but it does end up wiping out a lot of those beneficial insects. And also the recognition that when selected chemicals do need to be used, sometimes they're much more expensive and sometimes they can take longer to work. So integrated pest management can sometimes be a really difficult thing to implement on a farm because of these challenges, but the long-term benefits end up being worth those challenges. So what can we in local communities be doing to help? I think one of the best things is just to understand what kind of beneficial insects are on your property. So using something like an iNaturalist app to record what kind of species are there, to understand whether they're pests or whether they're beneficials, and to just really start understanding those ecosystems and those food webs, and to use integrated pest management as a conversation starter in your local communities, to just share the success that you've had with not spraying insecticides, share all of the wonderful invertebrates that you're finding on your farms as a result, and talking about the long-term benefits of using integrated pest management in farming systems. Just creating space for invertebrates in all of the landscapes that we live in, so not just farms, but in our gardens and our cities, to not spray whenever we can avoid it, and to provide habitat for them where we can, just to start appreciating how important these invertebrates are in our systems, and of course supporting these wonderful local Landcare events and all the conservation groups that are doing amazing work in this area. As far as Invertebrates Australia are concerned, we do a lot of promotion of scientific research and conservation activities across Australia, and of course education events like this as well. It's really important and also enjoyable for us to be able to get out here and tell everyone about these amazing invertebrates. Keep an eye out for us in September, October this year when we launch our No Spray Spring campaign, where we give a whole lot of information about amazing predators that are living in our systems, how they can be controlling pests, and ways that we can reduce spraying in our farms, in our gardens, and across Australia. So thank you so much for listening. If you'd like more information, you can visit Invertebrates Australia, and I really hope that you're able to get out and appreciate all of the beneficial insects that you see in your local area. Thank you.